All right, good afternoon, everyone. We're going to go through a couple of problems talking about unit analysis, and I wanted to take a few moments to do a couple of practice so that you would understand what it is that you're going to be expected to do. Now, these are taken directly from your textbook from the chapter review, and I'm going to be using page 10, the table 1.2, in order to have a reference for the prefixes. As time goes on, you want to have these prefixes and the numbers that they represent memorized. So you want to keep studying and keep trying to prepare. Remember, as I said in the video, King Henry died by drinking chocolate milk, making noise. So let's go ahead and look at letter A to get us started. The information that I have is, the question says, how many kilograms are there in 1 teragram? Now, teragram is going to be very, very large. Think in your mind like a terabyte. It's 1,000 kilobytes, right? Or gigabytes, sorry. So we're going to take this a little bit further, and now we need to set up what we call our unit analysis table, or our T-chart. So once my T-chart is set up, I need to get rid of teragram. That's the unit that I have currently. So what I'm going to do is I'm going to bring teragram down to the bottom and determine how many grams there are in 1 teragram. Looking and using the information we have in the table, I know that there are 1 times 10 to the 12 grams in 1 teragram. That's a lot. So now I can go ahead and cancel out my teragrams, and I'm left in grams. My goal is to get to kilograms, so I have to fix that. Now, again, I want to get rid of grams, so I need to bring grams, unit grams, down to the bottom. Now, how many grams are there in 1 kilogram? Or how many anything are there in a kilo, whatever? And that's going to be 1,000. You see 10 to the third, same as saying 1,000. So go ahead and write that in, my 1,000 grams at the bottom and my 1 kilogram at the top. I know I'm ready to stop because I see that I have kilograms in the top right-hand corner. That's the last one that hasn't been canceled out. So next thing, multiply what's on the top and divide by everything on the bottom, and I'm going to come out with my final answer of 1 times 10 to the 9th kilograms. So I have a lot of kilograms in that space. Now, we want to look at a couple more examples just to set you off and set you up so that you can go ahead and practice this on your own. So let's look at another example. We're looking at part B. And the question is, how many nanometers are there in 6.5 times 10 to the second terameters? So let's take a moment and look. We're going to set up our table again, and you're going to get through the process of this. So I set up my table with my given information in the top left corner. Now, again, I need to get rid of my terameters, so my intermediate in this case is going to be meters. So how many meters are there in 1 terameter? Using my chart, I'm able to find out that there are 1 times 10 to the 12th meters in 1 terameter. This allows me to cancel out my terameters and be left with meters. But I have to keep going. From this point now, I need to go on to nanometers. So again, I have to ask the question, how many nanometers are there in 1 meter? Knowing that a nanometer is much smaller than a meter. So, using my chart, I find that a nanometer is 10 to the negative 9th of 1 meter. So 1 times 10 to the 9th nanometers are present in 1 meter. Now, in your mind, you're probably saying, okay, it was negative on the chart. Why is it now positive? We're asking the question, how many of these are actually present? Being that that's the case, that means I'm going to need a positive number. So what I did is I took this value that was given to me and used it to divide by 1. Divided 1 by that number. In doing that, that gave me this very large number. Now, multiplying across the top and dividing by the information on the bottom, which in this case is 1, will give me my final answer of 6.50 times 10 to the 23rd nanometers. Now, mental check. I'm going from a terameter, which is very, very large, to a nanometer, which is very, very, very small. Is this number consistent with my calculations? These are things that you always want to check. If you're going from larger to smaller or smaller to larger, whichever the case may be, you want to make sure that your answer is consistent with where it should be, keeping our accuracy and our precision very, very close. Now, one more example, and then we're going to go ahead and set you up with a challenge problem, which you'll do on your own. We want to convert from micrograms all the way to picograms. Micrograms to picograms. Going through the process before, we need to get rid of that microgram, so how many micrograms are there in 1 gram? 1 times 10 to the 6th micrograms are present in 1 gram. The micrograms at the bottom, so I'll be able to get rid of it to cancel it out, and 1 gram left at the top. Now, again, how many picograms are there in 1 gram? Now, we have our 1 times 10 to the 12th picograms present in 1 gram. Just following the same pattern, you notice it went all the way through to completion. Multiplying what's on the top, dividing by what's on the bottom, and we end up with 1.06 times 10, 1.0 times 10 to the 6 picograms present in 1 microgram. So we still have a fairly large number present within that. Now, how do you check? A picogram is much, much smaller than a microgram. If we're looking at the values, we go from 10 to the negative 6 to a picogram, which is 10 to the negative 12. So this number is consistent with our answer, and with our calculations are correct. Now, here is your challenge question. I want you on your own to convert 294.5 nanometers into centimeters. Take your time. If you run into any questions, feel free to email me and let me know what's going on. Have a great evening. I'll look forward to your responses, and I'll see you in class.